2022 bracket 2023 A-Level Combined Mathematics Paper 1 Part B question number 17. This video is being done by special request of user Abdullah s6k. If you yourself have such requests and want me to do videos on them, then post them in the comments down below or in the comments of my other videos, and I will most likely check them and make similar videos to this one on those requests. So moving on to the question, part A says, write down cosine of A plus B in terms of cos A, cos B, sin A and sin B, and it then says, and obtain a similar expression for sine of A minus B. Now when it says write down, it means that we don't actually prove anything. We can directly write down an identity that we know and substitute into it in order to get the cosine of A plus B in terms of cos A, cos B, sin A and sin B. But when it says and obtain, it usually means that we need to use that equation that we just wrote and do some kind of clever substitution into that equation in order to obtain the sine of A minus B in this particular case. Now when I solve this question, you will see exactly what I mean by this. So anyway, moving on to the next part, it says let k be an element of the real numbers and k not equal to 1. And then by separately considering the cases where k is greater than 1 and k is less than 1, it asks us to express 2k cosine of theta plus pi by 3 plus 2 sine theta minus pi by 6 in the form of r times cosine of theta plus alpha, where r, which is a positive number, is in terms of k, and alpha, which is an angle in between 0 and 2 pi radians, are real constants to be determined. It then finally says, hence solve 2k times the cosine of theta plus pi by 3 plus 2 times the sine of theta minus pi by 6 equal to the modulus of k minus 1. Now here we'll probably have to use the cases of k greater than 1 and k less than 1 separately in order to solve this question. Now moving on, for the first part of the question, we have to find the cosine of a plus b, and since we are told to write it down, we can directly write the identity that we know. So from our video on trigonometric identities, we know that the cosine of a plus b is equal to the cosine of A times the cosine of B minus the sine of A times the sine of B. Now, for the sine of A minus B, the substitution that I'm going to do into this formula is to, instead of writing A, write pi by 2 minus A, and you will see exactly what I'm doing this. So if I write that down, I can write the cosine of pi by 2 minus A as the first angle plus B. And what I'm going to do first is to directly substitute into this expression here, taking the first angle A as pi by 2 minus some angle A. So doing that, I can see I'm going to get the cosine of A, which is going to be the cosine of the first angle, which is pi by 2 minus A times the cosine of B times the cosine of B minus the sine of the first angle, which is the sine of pi by 2 minus A times finally the sine of the second angle, which is the sine of B. Now, on the left hand side, I'm going to rearrange this thing a little bit by writing this as the cosine of, I'm going to take the pi by 2 out as a pi by 2, and I'm going to take this minus a into a bracket that has a minus in it, and I'm also going to take the plus b into that bracket. Now if I take the a into the bracket, since it's minus a, the minus stays on the outside and we get plus a on the inside. However, for the plus b, since plus b needs to be written as plus in the very end, we need to write this as minus minus b. Since if you take minus minus b, you're going to get plus b on the outside of the bracket. So now we have this. On the right side, we can see we have the cosine of pi by 2 minus an angle, and also over here we have the sine of pi by 2 minus an angle. Now as we know, the cosine of pi by 2 minus any angle is the sine of that angle, and the sine of pi by 2 minus any angle is the cosine of that angle. And therefore, the cosine of pi by 2 minus a is the sine of a, so we have the sine of a times the cosine of b times cosine of b minus, and this thing also is the sine of pi by 2 minus a, which is the cosine of a times then the sine of b. Now, if we take a look at the left hand side, we can see the left hand side is also of the form cosine of pi by 2 minus some angle, and therefore it will be the sine of that same angle. So therefore the left hand side here is going to be equal to the sine of a minus b, and the right hand side is here is going to be equal to the sine of a times the cosine of b minus the cosine of a times the sine of b. And we can see here what we obtained is an expression for the sine of a minus b in terms of sine a, sine b, cos a and cos b. So this is exactly the answer that we wanted. Now how would you know what kind of substitution that you need to do here in order to obtain this result? Well, to be honest, you just have to know. You just have to take a look, see what kind of different substitutions you could get. You have to know that if you have the cosine of pi by 2 minus an angle, it will get you the sine of that angle. And by deducing that, you then use a proper substitution in order to find the sine of a minus b in terms of this expression by substituting the cosine of a plus b, this kind of expression. So now that we've done that, we can now move on to the next part of the question. Now for the next part of the question, we have to convert 2k cosine of theta plus pi by 3 plus 2 sine theta minus pi by 6 into the form of r times cosine of theta plus alpha. And due to this, we can see, if we just expand this for a moment, we are going to have to convert this into the form of r times, if we expand the cosine of theta plus alpha, is going to be cosine of theta times cosine of alpha minus sine of theta times sine of alpha. And therefore, if we want to rearrange this into this form, we need to rearrange this expression right here into some r on the outside times cosine of theta times the cosine of some angle minus sine of theta times the sine of some angle. So we need to basically reduce this into sine of thetas and cosine of thetas and then group them such that we have the form of r times cosine theta times cosine alpha minus sine of theta times sine of alpha. So with that goal, let's start expanding the expression on the left hand side into something that can be formed into the expression on the right hand side. So for the left hand side, we have 2k cosine of theta plus pi by 3. So going down, we have 2k cosine of theta plus pi by 3 plus 2 sine theta minus pi by 6. So we know we're going to have to expand this eventually. And in the first part of the question, we were asked to find the cosine of a plus b and the sine of a minus b. So therefore, as a first step, let's expand this and this using those two formulae. So from this, we're going to get equals 2k times the first expansion, which is going to become cosine of theta times the cosine of pi by 3 minus sine of theta times the sine of pi by 3. And then the second part is going to become plus 2 times, and then the sine's expansion is going to be sine of theta cosine of pi by 6 minus cosine of theta sine of pi by 6. Cosine of theta sine of pi by 6. Now, simplifying this down, we can see on the left hand side we have 2k times cosine of theta times the cosine of pi by 3, which is going to be equal to half, minus sine of theta times the sine of pi by 3, which is going to be root 3 over 2. So times root 3 over 2. Plus, and the second part is going to be 2 times the sine of theta times the sine of pi by 6, which is going to be sine of theta times root 3 divided by 2, minus the cosine of theta times sine of pi by 6, which is going to be the cosine of theta times 1 over 2. Now expanding this out, we can see on the left hand side, if we cancel this half here and the half here to the 2 on the outside, we have equal to k cosine theta minus root 3 k sine theta. And then over here, if we take this 2 and this half and cancel them, we're going to be left with plus root 3 sine theta minus cosine theta. And now we can see, if we group them based on the sine and cosine, the cosine of k times cosine of theta and minus cosine of theta is going to give us equal to k minus 1 times cosine of theta, and this part right here can be grouped to give us either minus root 3k plus root 3, or if we take the minus outside, minus root 3 times k minus 1 times the sine of theta. Now we can see, factoring out the k minus 1, we're going to get k minus 1 multiplied by 1 times cosine of theta, which I can take as 2 times a half times cosine of theta, minus, and instead of root 3, if I take the 2 out, we're going to have root 3 divided by 2 times the sine of theta, close bracket. Now the reason I took the 2 out here and put a half in front of the cosine theta and root 3 over 2 in front of the sine theta is because in the end what we wanted is to have the form of cosine of theta times cosine of alpha minus sine of theta times sine of alpha. And now when we do this, we can see we have the cosine of a certain angle and the sine of a certain angle here. The angle, of course, is going to be pi by 3. So if I write this down, this is going to be 2 times k minus 1 times, and this half here can be written as the cosine of pi by 3, so we can write cosine of theta times the cosine of pi by 3 minus, and root 3 over 2 is the sine of pi by 3, so we can write minus sine theta times the sine of pi by 3. Now we can see here, if we were to directly take this and convert it into a single cosine of an angle, we would get the cosine of theta plus pi by 3. So therefore this is equal to 2 times k minus 1 times the cosine of theta plus pi by 3. So for now this is our answer. But remember, we need the form r times cosine of theta plus alpha where r is positive. But if k is something that is less than 1, then we can see k minus 1 would be negative, and therefore we would have a negative value in front of the cosine, which would mean that it is no longer valid for r, since r needs to be positive value. So therefore, considering the two cases, for the positive case where k is greater than 1 is going to be fine, but for the negative case we're going to have to do something special. So if we now consider the two cases, considering the first case, which is the case where k is greater than 1, we can see since k is greater than 1, k minus 1 would be greater than 0. And therefore, 2 times k minus 1, which is the thing that we have at the front here, would be greater than 0. Now, in a form that they gave us, we wanted the form of r times the cosine of theta plus alpha, where r is greater than 0. In this particular case, r is in fact greater than 0 if we let r be equal to 2 times k minus 1. And then the angle alpha is pi by 3, which is in fact in between 0 and 2 pi radians. So therefore, if we let r be equal to 2 times k minus 1, r equals 2 times k minus 1, 2 times k minus 1, and we let alpha be equal to pi by 3, then this is one valid solution for this thing for the case where k is greater than 1. And therefore we can write that therefore we have the condition that we wanted, which is 2k times the cosine of theta plus pi by 3 plus 2 times the sine of theta minus pi by 6 being in the form of r times cosine of theta plus alpha, and hence we have solved for the case that k is greater than 1. Now that's all well and good, but if we then consider the case where k is less than 1, if we consider case k less than 1, we will run into an issue, because if k is less than 1, then k minus 1 would be less than 0, and therefore we can no longer use r equals 2 times k minus 1, because then r would be negative, and as they said above, we clearly need the case that r is a positive number. So therefore, we cannot use r equals 2 times k minus 1. However, if k minus 1 is negative, you can note that 1 minus k would then be positive. Now if 1 minus k is positive, and if we rearrange this to take a minus sign out here, then we could write r equals 2 times 1 minus k. But then we would have to take that minus and put it inside of the cosine in order to make it work. So considering doing that, we can write this as being equal to 2 times k minus 1 times the cosine of theta plus pi by 3. We could write it as being equal to 2 times 1 minus k times negative cosine of theta plus pi by 3. Now, we cannot keep this negative sign around. We need to get rid of it, because in the form that we have r times cosine of theta plus alpha, and there's clearly no negative there. So therefore, we need to get rid of it. Now you will note we have the negative cosine of an angle. And as we know, the negative cosine of an angle is that angle plus pi radians. There are other expressions that you could also use, but this expression will give you the negative cosine of an angle as the cosine of pi plus that angle. And therefore, we could write this as 2 times 1 minus k times, and instead of having the minus out here, we could write this as the cosine of pi plus the internal angle here, which is plus theta plus pi by 3. Now if we write it like this, we can see if we take the pi and the pi by 3 into one single value, we can get this being equal to 2 times 1 minus k times the cosine of theta plus 4 pi by 3. Now you will note we have the form of some value on the inside and some value on the outside, where the value on the outside is just a number and the value on the inside is some value in between 0 and 2 pi radians, and the value on the outside is positive. So therefore, now that we have this form, we could say r equals 2 times 1 minus k and alpha equals 4 pi by 3, and we have the conditions that they gave us above, where r is a positive number and alpha is some angle in between 0 and 2 pi radians. So therefore this is a valid solution, and we can then finally say that therefore we can rewrite 2k cosine of theta plus pi by 3 plus 2 times the sine of theta minus pi by 6, which is what we had initially, as in this case r times cosine of theta plus alpha, where r is a positive number and alpha is some angle in between 0 and 2 pi radians, where in the case of k being any value less than 1, it's going to have r equaling 2 times 1 minus k and alpha equaling 4 pi by 3. So therefore, we've solved for the two cases separately. We've solved for the case where k is greater than 1, and we've also solved for the case where k is less than 1. And we can see we get two separate solutions for those two, which have same form of r times cosine of theta plus alpha, but we have different r's and different alphas because of the condition that r needs to be a positive number and alpha needs to be an angle in between 0 and 2 pi radians. So now we can move on to the last part of the question. So now for the last part of the question, we need to hence solve 2k times the cosine of theta plus pi by 3 plus 2 times the sine of theta minus pi by 6 equal to the modulus of k minus 1. So considering this, if we go down and write this, we need to solve for 2k cosine of theta plus pi by 3 plus 2 times the sine of theta minus pi by 6 equal to the modulus of k minus 1. Now considering the left hand side, as we saw above, if you consider k greater than 1 and k less than 1, then you can write the left hand side in two different ways. Now considering those same exact cases, if we look at the right hand side, we can see for k greater than 1, k minus 1 is positive, and therefore the modulus of k minus 1 is k minus 1. However, if k is anything less than 1, then k minus 1 will be negative, and therefore the modulus of k minus 1 is going to be 1 minus k. So we can see for these two cases where k is greater than 1 and k is less than 1, both the left hand side and right hand side have two different values. And therefore, if we consider two cases, for the first case where k is greater than 1, we can see the left hand side is simplified to, as we found above, 2 times k minus 1 times the cosine of theta plus pi by 3. And on the right hand side, the modulus of k minus 1 will simplify to just k minus 1. Since k minus 1 is positive, modulus of k minus 1 is just k minus 1. Now we can see here on the left hand side we have k minus 1, and on the right hand side we have k minus 1. So therefore we can divide both sides by k minus 1 and say that 2 times the cosine of theta plus pi by 3 is equal to 1. Now if we're dividing both sides by k minus 1, we must make sure that k minus 1 is not equal to 0, and hence k is not equal to 1. But as we were told in the question, k is anyway not going to be equal to 1. So we need to mention that, and we need to mention that as a reason that we can divide both sides by k minus 1. So we can say this can be the case because k is not equal to 1 as given in the question. So now simplifying this thing down, we can see if we divide both sides by 2, we get the cosine of theta plus pi by 3 would be equal to 1 divided by 2, and 1 divided by 2 is also equal to the cosine of pi by 3. And therefore we have the cosine of theta plus pi by 3 being equal to the cosine of pi by 3. Now from this we know if the cosine of any angle A is equal to the cosine of any angle B, then A must be equal to 2n pi plus or minus b, where n is an integer. And therefore here we can write that theta plus pi by 3 must be equal to 2n pi plus or minus the other angle, which is pi by 3, for n element of the integers. And therefore simplifying this down, theta must be equal to 2n pi minus pi by 3, again plus or minus another pi by 3, for n element of the integers. And therefore that's going to be the solution for k greater than 1. Now considering the second case, for case where k is less than 1, on the left hand side we know that this thing simplifies down to 2 times 1 minus k times the cosine of theta plus 4 pi by 3. Now for the right hand side, we have the modulus of k minus 1, which if k is less than 1, then k minus 1 is going to be negative, and therefore we're going to have 1 minus k as our answer. So therefore on the right hand side, we're going to have 1 minus k. Now considering this, we can see once again we have 1 minus k on both sides, which means we can divide by 1 minus k, leaving us with 2 times the cosine of theta plus 4 pi by 3 equal to 1. Now once again we need to justify this, and we need to say this can be done because k is not equal to 1, and therefore k minus 1 is not equal to 0, so we can divide by k minus 1 on both sides without a problem. So now we can see this is going to lead us to cosine of theta plus 4 pi by 3 being equal to 1 over 2, which is equal to the cosine of pi by 3, and hence if cosine of A is equal to cosine of B, then theta plus 4 pi by 3 must be equal to 2n pi plus or minus the other angle, which is pi by 3, again for n element of the integers. Now in this particular case, since I used n above and in here also, I'm actually going to replace n with m, just for the sake of disambiguating between the two. So instead of n here, I'm going to write 2m pi plus or minus pi by 3, for this time m element of the positive integers. Not positive integers, I apologize, m element of the integers. So now finally, we can rearrange and get that theta is equal to 2m pi minus 4 pi by 3 plus pi by 3, or rather plus or minus pi by 3 for m element of the integers. And now with that, we have solved for both cases where k is greater than 1 and k is less than 1 for 2k times the cosine of theta plus pi by 3 plus 2 sine theta minus pi by 6 equal to the modulus of k minus 1. And hence, this part of the question is solved. Now moving on from part A, if we go to part B says, in the quadrilateral ABCD shown in the figure, AB length is 2p, CD length is 4p, and ACB angle is pi by 6, and ABC angle is equal to ACD angle is equal to alpha. Now given this information, we are asked to show that AD squared is equal to 16p squared times sine squared alpha minus sine 2 alpha plus 1. And then we are asked to hence show that if AD length is equal to 4p, then alpha is equal to tan inverse of 2. Now considering this, what we have to do here is to apply the sine rule and cosine rule to these triangles. So going down, if we take a look, in order to find AD squared, we could apply the cosine rule to the ACD triangle, because the cosine rule states that the square of any side length squared is going to be equal to the first side length squared plus the second side length squared minus 2 times the first side length times the second side length times the cosine of the angle between them. So here, in order to find AD squared, we need to find the DC length, which we already know. We need to find the angle here, which is alpha, which we already know. And we also need to find the AC length. Now, we don't currently know the AC length. But if you take a look at the triangle ABC, you can see we know the angle opposite to the AC length, and we also know a pair of a side length and an angle opposite to it. So therefore, if we apply the sine rule to triangle ABC, we could find the AC length. And then if we substitute that into the cosine rule of ACD, we could then find the length AD squared. So considering that, what we need to do first is to apply the sine rule to triangle ABC. So we can say applying sine rule to triangle ABC, and if we do that, we can see the sine of this thing divided by the length, or we could say the length AC divided by the sine of alpha is going to be equal to the length 2p divided by the sine of pi by 6. And therefore, if we write that down, AC divided by the opposite angle sine, which is sine alpha, is equal to 2p divided by opposite angle sine, which is sine of pi by 6, which leads us to AC length equal to 2p divided by sine pi by 6, which is a half, times sine of alpha, which we can see if we simplify, we get AC length is equal to 4p sine alpha. We're going to call this equation number 1. Now, if we then apply the cosine rule to triangle ACD, we can see applying, if we go here and say applying cosine rule to triangle ACD, if we apply it, we can write down AD squared as being equal to DC squared plus AC squared minus 2 ACDC times the sine, or rather cosine of alpha. So therefore, we can write that AD squared is equal to AC squared plus DC squared minus 2 AC DC, quite funny, AC DC, times the cosine of alpha. So now, simplifying this thing, we can see we can substitute in AC as being equal to 4p sine of alpha, and DC, as we know, DC is equal to 4p, so we can directly substitute that in as 4p squared. So we can write 4p squared minus 2 times AC, which is 4p sine alpha, times DC, which is 4p, times the cosine of alpha. And we can see here inside of this thing we have 4p squared, in here we have 4p squared, and here also we have 4p times 4p, which can be taken out as 16p squared. Now considering what's left, in the first term we have sine squared, so therefore we have sine squared of alpha. In the second term we have 1, but I'm going to leave that at the end, since in the expression that we were given we had a plus 1 at the end. And then for this thing we have minus 2 times sine of alpha times cosine of alpha, which I'm going to write for now as minus 2 sine alpha cosine alpha. And then this thing, if we take 16p squared out, we're going to be left with plus 1, so plus 1. And we can see finally this can be written as 16p squared times the sine squared of alpha, and we know 2 sine alpha cos alpha is the sine of 2 alpha, so we have sine of 2 alpha plus 1, and therefore AD squared is equal to 16p squared times sine squared alpha minus sine 2 alpha plus 1, and so we solve that part. Now for the next part, they said, hence show that if AD is equal to 4p, then alpha must be equal to tan inverse of 2. So considering that, if we go down and say, if AD length is equal to 4p, then substituting we can say into the above equation, on the left hand side we're going to have 4p squared equals, on the right hand side we're going to have 16p squared times sine squared alpha minus sine of 2 alpha plus 1. Now simplifying we can see we have 16p squared on the left hand side, and on the right hand side we have 16p squared times sine squared alpha minus, and I'm going to expand this in back into 2 sine of alpha times cosine of alpha plus 1. So now here we can see if we simplify, we are going to get sine squared alpha minus 2 sine alpha cos alpha plus 1 equal to, and on the other side we're going to get just 1. So therefore we get that sine squared alpha minus 2 sine alpha cos alpha is equal to 0, and therefore if we remove the sine alpha out, we can see sine alpha times sine alpha minus 2 cosine alpha must be equal to 0. Now here we can say that directly sine alpha must be equal to 2 cosine alpha, and we can say this because sine of alpha is not equal to 0. So because sine of alpha is not equal to 0, we can say if we divide both sides by sine of alpha minus 2 cosine of alpha is going to be equal to 0, and therefore sine of alpha is going to be equal to 2 cosine of alpha, and therefore sine of alpha divided by cosine of alpha is going to be equal to 2, and we can say that this is also valid because cosine of alpha is not equal to 0, since if we are dividing by cosine of alpha we need to say this. And now we can see therefore tan of alpha, since sine alpha divided by cos alpha is tan of alpha, is equal to 2, and hence alpha is equal to tan inverse 2, and we need to say here alpha is equal to tan inverse 2 because alpha is in between 0 and 2 pi, or we would just say pi radians. Actually saying 2 pi would be invalid, I need to say pi, because since alpha is an angle inside of a triangle, it must be in between 0 and pi radians, and therefore if we have tan alpha equal to 2, then alpha must be equal to tan inverse of 2. And hence we've solved that part of the question, and now we can finally move on to part C of the question. Now for part C, we are asked to solve tan inverse of natural logarithm of x to the power of 2 over 3 plus tan inverse of natural logarithm of x plus tan inverse of natural logarithm of x squared equal to pi by 2 for x is greater than 1. To solve this, what we're going to do is to go down and we're going to define each of these angles here as being equal to certain values, let's say alpha, beta, and gamma. So basically here we have three angles, alpha, beta, and gamma, which when added together are equal to pi by 2, and alpha, beta, and gamma are in between negative pi by 2 and pi by 2 based on the definition of tan inverse. So now we know that. Now considering this, if we define them like this, we have to say let alpha be equal to tan inverse of the natural logarithm of x to the power of 2 over 3. We have to let beta be equal to tan inverse of the natural logarithm of x, and we have to let gamma be equal to tan inverse of the natural logarithm of x squared. Now, given these three, we can see if we took the tangent of both sides, we could convert these three into the form where tangent of alpha was equal to natural logarithm of x to the power of 2 over 3, tangent of beta was equal to natural logarithm of x, and tangent of gamma was equal to natural logarithm of x to the power of 2. Now, considering this, we can also simplify each of these further, because we know if you have the natural logarithm of x to some power, it's going to be equal to that power multiplied by the natural logarithm of x. So therefore, natural logarithm of x to the power of 2 over 3 is going to be equal to 2 over 3 times natural logarithm of x. This is going to, of course, still be equal to natural logarithm of x. And finally, natural logarithm of x squared is going to be equal to 2 times natural logarithm of x. Now, from this we can say that alpha plus beta plus gamma must be equal to pi by 2 based on the equation given. Now, if I take one of these angles to the other side, let's say alpha, we can see that this would mean that beta plus gamma must be equal to pi by 2 minus alpha. Now, so far we can't see why this would be useful, but consider taking the tangent of both sides. If we took the tangent of both sides, the left hand side would be the tangent of beta plus gamma, and the right hand side would be the tangent of pi by 2 minus alpha, and as we know, the tangent of pi by 2 minus any angle is equal to the cotangent of that angle, so it's cot alpha, which is equal to 1 divided by the tangent of that angle, so tangent of alpha. So now we know that the tangent of beta plus gamma is equal to 1 divided by tangent of alpha. Now, we can also expand the tangent of beta plus gamma in terms of tangent of beta and tangent of gamma. This expansion is tangent of beta plus tangent of gamma divided by 1 minus tangent of beta times tangent of gamma, and we can see that's equal to 1 divided by tangent of alpha. Now, considering this equation, you might notice that this equation only has tangent of alpha, tangent of beta and tangent of gamma, which, as we found, can all be written in terms of natural logarithm of x. So therefore, if we substitute into here, we are going to get an equation that is only in terms of the natural logarithm of x. So doing so, if we substitute, we can say substituting, we're going to get over here tangent of beta is natural logarithm of x, so we get ln x, plus tangent of gamma is 2 times natural logarithm of x divided by 1 minus ln x times 2 ln x equal to 1 divided by, and here we're going to get 2 over 3 ln x. Now, simplifying this thing here, we can see we have 3 ln x here, and if we take this thing to the other side, we can see we're going to get 3 ln x times 2 over 3 ln x, and for this part, if we take it to the other side, we're going to get equal to 1 minus ln x times 2 ln x is going to be equal to 2 ln x squared. So here we can see on the left hand side, if we cancel this 3 with this 3, we're going to get 2 natural logarithm of x squared. Over here we have another 2 natural logarithm of x squared, so therefore we get 4 natural logarithm of x squared being equal to 1, and hence we get natural logarithm of x squared being equal to 1 over 4, which is 1 over 2 squared, and hence if we consider that, we can get that natural logarithm of x must be equal to plus or minus 1 over 2. So we got this. We got the natural logarithm of x must be equal to plus or minus 1 over 2. Now, considering this, since x was greater than 1, as we said in the question, we are solving for x greater than 1, we can say the natural logarithm of x must be equal to the positive number here, which is going to be plus half, because x is greater than 1. Because if you consider x greater than 1, if x is greater than 1, the natural logarithm of x is going to be equal to the positive number, and therefore if it's equal to a positive number, then we can say the natural logarithm of x must be equal to positive half. So we can say that x being greater than 1 implies that the natural logarithm of x must be greater than 0, and hence it cannot be negative half and it must be positive half. And now finally, if we take e to the power of both sides, we can say on the left hand side we get x, and on the right hand side we get e to the power of half. And therefore, x is equal to e to the power of half, and that's going to be the solution for this part of the question. So now with that, we've solved all 3 parts of the question. So now finally, let's consider the marks awarded for this question. So for the first part of the question, when you write the cosine of a plus b in terms of cos a, cos b, sin a, and sin b like this, you get 5 marks. And then when you try to use that to find the sine of a minus b, When you do the substitution of the first angle being pi by 2 minus a, you get 5 marks. When you then apply the cosine of a plus b into that and get this equation right here, you get 5 marks. And then when you simplify, use trigonometric identities to eventually get that the sine of a minus b is equal to sine a cos b minus cos a sine b, you get another 5 marks. Now after that, for this part right here, when you write down the expression like this, and you simplify the cosine of theta plus pi by 3 into this expression right here, you get 5 marks for that. And you simplify the sine of theta minus pi by 6 to this expression right here, you get another 5 marks. Now after that, when you simplify, substitute in all of the trigonometric expressions and get this equation right here or something similar, you get 5 marks. And then when you group it into this form and you get 2 times k minus 1 times half times cosine theta minus root 3 over 2 times sine theta, you get 5 marks. And when you then substitute in the relevant trigonometric values of cosine of pi by 3 and sine of pi by 3 and then write that in the form of r times cosine of theta plus alpha like this, you get 5 marks. Now after that, when you consider the two cases, for the case where k is greater than 1, when you write down that r is equal to 2 times k minus 1 and alpha is equal to pi by 3, you get 5 marks. And for the second case where k is less than 1, when you write down that r must be equal to 2 times 1 minus k and alpha is equal to 4 pi by 3, you get another 5 marks. Now after that, when you then solve for the two cases, for the first case, when k is greater than 1, when you solve and eventually get that cosine of theta plus pi by 3 must be equal to cosine of pi by 3, you get 5 marks. And when you then write down this expression here for all of the possible solutions for theta, you get another 5 marks. Now similarly, for the second case where k is less than 1, when you find that cosine of theta plus 4 pi by 3 must be equal to cosine of pi by 3, you get 5 marks. And then when you write down the relevant infinite number of solutions like this, you get another 5 marks. Now after that, for the second part of the question, when you take this thing and you apply the sine rule for triangle ABC, for applying sine rule directly you get 10 marks, and then for writing down AC in terms of P and alpha like this, you get another 5 marks. Now after that, similarly, for applying the cosine rule to triangle ACD, when you write down the expression that you have, you get 10 marks, and then when you simplify it down to the answer that you need, you get another 5 marks. Now after this, when you substitute in AD equals 4p and you get the expression sine squared alpha minus sine 2 sine alpha cosine alpha plus 1 equals 1, you get another 5 marks. And then when you simplify that to sine alpha equals 2 cosine alpha, since sine alpha is not equal to 0, you get another 5 marks. And finally, when you get the final answer of alpha is equal to tan inverse of 2, due to these conditions, you get another 5 marks. Now after that, for part 3, when you expand this thing with certain angles like this and rearrange it into this form, where you have alpha plus beta plus gamma equal pi by 2, and then you rearrange it to beta plus gamma of two angles summed together equal pi by 2 minus the other angle, you get 5 marks for that. And then you take the tangent of both sides, you get 5 marks. And then when you expand the tangent of a plus b into tangent of a plus tangent of b, divide by 1 minus tangent of a times tangent of b, you get 5 marks for that. And finally, when you substitute the tangent of the three angles like this, you get another 5 marks. Now after that point, when you then simplify for a quadratic and get the natural logarithm of x squared must be equal to 1/2 squared, you get 5 marks. And then when you solve for the positive value, since we know that x is greater than 1, meaning the natural logarithm of x is greater than 0, and you get the solution of x equal e to the power of half, you get a final 5 marks. So that is going to be all for this question and all for this video. So I hope you enjoyed. If you have any feedback or other requests, post them in comments down below. Thank you for watching and goodbye.